Hello everyone! Previously, we formulated Flair Furniture Company example into a linear programming problem. Now, let's talk about how to solve that problem. We will show you how to solve the problem in two ways. First, we will solve the problem graphically. Well, that is a manual way to solve a problem, so it's slow. Then we will show you how to use Excel solver to solve the same problem. Okay, here's the problem formulation for the Flair Furniture Company case. Let me remind you that you can solve a problem graphically only when it has two decision variables. In this example, the two decision variables are t and c. You will not be able to solve a problem graphically if there are more than two decision variables. This problem looks pretty complicated. Where can I get started? If you take a look at the problem, it basically has two parts. The objective on the top and constraints on the bottom. Since I need to make sure the value of t and c need to meet all the constraints, maybe we can start by identifying the set of decision variables that can satisfy all constraints. So let me start off from there. I'm going to graphically solve the problem. So let me start by drawing the two axes, one for t and one for c, just like here. By having these two axes, I already captured the two non-negative constraints, since my graph only contains the first quadrant where both t and c are greater or equal to 0. Okay, next, how do I graphically represent the first constraint, 4t plus 3c less or equal to 240? Well, the less or equal to sign is troubling me, so let me temporarily change it to equal to, just like this. I know 4t plus 3c equal to 240. This is a line. I know how to draw a line. All I need to do is to find 2 points on this line and connect them. So let me do it. By the way, how do you find a point on the line? Well, that's quite simple. All you need to do is to give a value to either t or c, and then use this equation to find out the value of the other variable. So let me try to set t to 0. Let me tell you, you do not necessarily need to use 0. Okay? I'm using 0 simply it makes my calculation easy. Okay? You can use other values too. Okay, so once I plug this into this equation, it simply implies 3c equal to 240, which is the same as saying c equal to 80. So at this point, I conclude that I find a point on this line. The coordinate of this line is 0, 80. So this is the first point. Now let me do that again, but this time I'm going to set c equal to 0. Again, now plugging this into this equation, it will lead to this result, 4t equal to 240, which is the same as saying t equal to 60. So I find another point, the coordinate is 60, 0. Okay, now let me identify these 2 points on the graph. The first point is 0, 80, it's over here. The other point is 60, 0, it's over here. Now let me connect these two dots. So here's the line, and this is the line called 4t plus 3c equal to 240. But wait a minute, what we really want to express is 4t plus 3c less or equal to 240. All we have now is a line which means it's equal to 240. So how do we accommodate this less or equal to? Well, let me tell you, less or equal to 240 simply means either left hand side or right hand side of this line. So which side is it? There's one easy way to tell, which is let's try out this point. Okay, let's plug this 0, 0 into here and see if this inequality holds. If it holds, then 0, 0 is on the side that satisfies this inequality. So let's do that. So let's plug it in. 4 times 0 plus 3 times 0, apparently still 0. it is indeed less or equal to 240. So we conclude that this point is on the side of this line that satisfies this inequality. So that tells us this whole shaded area satisfies this inequality. And what that again really means is every point in this shaded area, including every point on this line, satisfies 4t plus 3c less or equal to 240. Okay, now let's do the same to graphically represent the second constraint over here. Again, let me change the less or equal to sign to equal to, okay, to express this as a line, and I'm going to draw the line. To draw the line, again, I need to identify 2 points on this line. As before, I'm going to first set t to 0 and plug this into here. That will lead to c equal to 100. And that means I have identified the first point. The coordinate is 0, 100. Now I'm going to move on to find the second point, but this time I'm going to set c to 0. Again, you can choose different numbers. I'm picking 0 because it's easier to calculate. Plugging this into here, I get 2t equal to 100 or t equals to 50. So I have identified another point called 50, 0. So I have 2 points on this line. Now let me identify those 2 points in the graph. So the first point, 0, 100, is over here. Second point, 50, 0, is right here. Let me connect these two. So this is a line called 2t plus 1c equal to 100. Next, we need to identify which side of this line satisfies this less or equal to sign. So again, all we need to do is to check out this point, 0, 0, to see if it satisfies the inequality. So plugging 0, 0 to here, we got 2 times 0 plus 1 times 0, which is 0. So indeed, 0 is less or equal to 100. So again, the origin point is on the side of this line that satisfies this constraint, this inequality. So we conclude that the entire yellow shaded area satisfies this constraint. So every point in this shaded area satisfies this whole constraint. The whole area, including this line, satisfies this constraint. In the end, we need to identify points that satisfy all of the constraints. Which area satisfies all of the constraints? Well, you probably already guessed it. It is the overlapping area. It's the overlapping area over here. So it is this green area. Okay, this green area is the overlapping area between the yellow and green areas. This is a very special area and we have a name for it. We call this the feasible region. What makes the feasible region special is that every point in this region, including the ones on the red border, they all satisfy all of the constraints over here. In other words, every point in this region is a feasible candidate for the solution. All we have to do next is to identify which point or points in this feasible region is the best for our objective, and that will be our solution.